So we call this is operator precedence. It means we need to check what are the operators before we do the operation. For example, plus minus. This is unary plus and minus. It means if a number is positive or negative, then it will be the first. And then they will check the exponent. Exponent means 2 star 2. What is the result? It is the same with the 2 exponent 2. Okay. So this is the second. And then we have not. And then we will do this operation, multiply, division, integer division, modulus, or remainder. And then we will check the plus and minus. And then we will check the comparison. So the comparison means less than, equal, greater than equal. And then we have the equal, not equal. And then we will check and or, and this is the last, the assignment operator. So because this is the precedence, it will follow the order. This will be checked first, and then this, and then this, and then this, and then this, and so on. So it will be based on this order. When we deal with the operator precedence, the expression in the parenthesis, parenthesis, perlu. Okay. So if you have two plus 3 plus 4 multiply by 3. Okay. Then, this will be added first. Of course, this is higher precedence because of the multiply, but Python will consider the parenthesis first. So parenthesis can be nested, in which case the expression in the inner parenthesis is executed first. So for example, I have this, let's say 2 plus 3 multiplied by 4. So I will do this parenthesis, and then I will do this parenthesis. Then it means this is nested. Okay, so we will do this one first, and then we will do the outer parenthesis. So when evaluating the expression without parenthesis, so if there is no parenthesis, then the operators are applied according to the precedence rules and the associativity rules. So if there is no parenthesis, we will follow this order, or we call it, this is the rule. Okay, this is the rule. So if the operators with the same precedence are next to each other, their associativity determines the order of evaluation. So if we have 2 plus 3 minus 1 plus 4, because we know plus and minus, they are in the same order, then we will just check the associativity from left to right. All binary operators except assignment operators are left associative. If we have variable x equal to 5. So this is, we call it left associativity. So if I have x equal to 2 plus 3 minus 1 plus 5, then this is also left to the right, but except this one. It means we will do this one after we finish with this binary operator. So this is an example. So when two operators with the same precedence are evaluated, the associativity of the operators determines the order of evaluation. So all binary operators except assignment operators are left associative. So let's say this one, A minus B plus C minus D, then it is the same with this. Assignment operators are right associative. Right associative means we consider the right section. For example, like this one. A equals to B plus equal to C equals to 5. What does it mean? Then we will do from the right. So from the right means this one first. And then after we finish with this one, we will do this one. And then the result of this one will be the value of it. Now, let's see another problem. We have a palindrome number. Have you ever heard palindrome? Palindrome. There are some palindrome. We can have palindrome number. We can have palindrome string. So in this case, we are just focusing on number. Write a program that prompts the user to enter a 3-digit integer. So 3-digit integer means 3 numbers. And that means whether it is a palindrome number. A number is a palindrome if it reads the same from the right to left and from the left to right. So 1 to 1 is palindrome because from left we have 1 and 2 and 1. From the right we also have 1, 2 and 1. 131 is palindrome. 112 is not palindrome. Okay. So how we can make this one? So I give you the solution. So let's see. So I have a variable num, and this will be the input from the user. So let me run this. Enter a 3-digit integer. Let's say 888. Okay, 888 is a palindrome. So how this program works? Let me make a new variable n. So n, big N is a value from the user input num. And then I would like to divide with 100. So if we have 8, 8, 8, what is 8, 8, 8 divided by 100? It is 8. So N1 will be equals to 8. And then num will be divided. We will do the remainder with 100. What is the remainder with 100? 8, 8, 8, remainder 100. So we will get the remaining values. The remaining value is 8. So now, 8, 8, 8 remainder by 100. The remaining will be 88. This one. Now I have the N2. So if you look at this one, what is this formula? We have the num. The new number will be the old number remainder by 100. It means once we do the remainder, 8 remainder by 100. So the new variable, the new value here, the new value of this num will be 88. And then we will do N2 equals to num divided by 10. So N2 now becomes 88 divided by 10. 88 divided by 10. So we have 8. And then again we will do num equals to num remainder 10. So the last digit will be the remaining value, which is 8. With the condition, okay, we want to check whether the N1 and N3, which is the last digit, whether it is equal or not. So if it equals, then it is a palindrome. If it is not equal, then it is not a palindrome. Okay, so this is the code. Okay, so yeah, we learned about this condition. We call this is the condition, or sometimes we call it the selection. So we learn about the Boolean types, true or false. And then we learn about conditional, which is if, else, if, and else. We learn about nested if, and we learn about the logical operators. So the logical operators, we learn about the less than, equal, and so on. And then we learn about and, or, and not. Okay, so please remember about what we learned in this condition sections. Now let's move to the next section. For the next section, we are going to learn about repetition. And for this example, if you look at the E-class, I give you the code. Yeah, I give you chapter 04.zip. So I put everything on the chapter 04.zip. So please get the code from this zip, because it is a zip file, so you need to extract. Okay. 압축 풀기 here. So let me just put in this folder. So I have everything here. So this is all the code about the chapter 4. I call it, this is chapter 4. It is about the repetition. And if you want to copy and paste all the code, so you can just Control A, okay, and then copy them, Control C. Okay, so select all and then Control C. Now I would like to make a new folder in the PyCharm. So in the PyCharm, I would like to make a new folder, a new directory. Let's say the name is chapter 04. And then in this chapter 04, I would like to paste all the codes that I already copied from the folder. And you will get all the codes that you copy. Now they are in the chapter 04 folder. So we are going to use all the code here. Okay. So I do not give the code in the PowerPoint. So you just copy and paste all the codes in your PyCharm environment. So now let's look at the repetition. So we are going to learn some concepts about loops. We call it repetition. So we are going to use while and for loop. The second part, we are going to learn about the nested loops. The nested loop means multiple while, multiple for loop, and then some other condition, like we can use break, continue, and sentinel value. Okay, let's look at the repetition. Why we need to have repetition? Suppose you want to print a string. Programming is fun, like this, and you are going to print 100 times. What will you do? Are you going to print like this one for 100 times by copy and paste, copy and paste, copy and paste? Yes, of course it is okay. You can make let me make testing. So print programming is fun. Okay, so one time, and then you just copy and paste for 100 times. Is it okay? Yeah, of course it is okay, but it takes a lot of time to copy and paste one by one. And yeah, there should be a way how to solve this problem without copy and paste mechanism. So we can make a very simple loop. We can just make using while. If you learn the previous section, we learned about if. So now we are going to learn about while. The same thing in this statement, we need to have a condition. So this condition, while count is less than 100. So it means if this condition is true, so we are going to execute this statement. Count equals to 0. So 0 is less than 100. Yes. Because 0 is less than 100, then I would like to print programming is 1. Now count will be added by 1. So 1, we will check again to the condition. 1 is less than 100. Yes. Then we will print this one again. So count will be added by 1. Now it becomes 2. Again, we will check this condition. 2 is less than 100. Yes. So it will be repeated until 99. After we reach 99, 99 is less than 100. Yes. Then we will print programming is 1. Now 99 plus 1 becomes 100. So when we have 100, 100 is less than 100. False. Since it is false, then we stop. So you can do this one. So there are 100 times of what's programming is found. You can change this one. Let's say I want to make only 10. So you can see there are 10. Oh, I want to make it in just 5. Okay. So you can make it 5 times. Okay. So this is a condition, but we are not using if, we are using while to make it a repetition. If you use if, then you will see only one time. If you use while, you will see it is based on the condition. Whenever it is still true, then it will be again, and again. So we can look at the flowchart. How to deal these things with the flowchart. We have the loop continuation condition. So this is the condition. If this is true, so we will do it again. And then check until the condition becomes false. So here we start with the count equals to 0. So if the condition is true for count less than 100, then we will print programming is 1. Count will be added by 1. And then go here. Check again. Count is less than 100. If it is still true, then we will do this one. And so on until the condition becomes false. So if we want to see how the program works, as you know, the program will start from the top to the bottom. We will start from the count equals to 0 and then check. Count is less than 2. Yes, it is true. So we will print programming is 1. Now increase the count by 1. Now count equals to 1. Check whether 1 is less than 2. Yes, it is still true since count is 1. Now again print programming is 1. Sorry, this is mistyping. And then now count will be added by 1. Count becomes 2. And then we will check. 2 is less than 2. It is false. So we will stop from the loop. For this kind of loop, in order to stop the execution, something has to happen inside the loop to make the condition false. So the iteration means one execution of the body of loop. We call this is while loop because we have a pre-test. What is pre-test? Pre-test means we have the condition while count less than 100. So we have the condition at the first time. We call it this is pretest. So this pretest, we want to test the condition before performing an iteration. Before we start the statement, so we check whether this is true or not. So it will never execute if the condition is false to start with. So if the condition is false at the first time, then we will not do this statement. And it requires performing some steps prior to the loop. So maybe sometimes we need to do something before the loop. For example, we need to initial the value, count equal to 0, or C equal to something. Be careful with the infinite loops. What is infinite loops? So loops must contain within themselves a way to terminate. Terminate means, we need to find something so the loop will be stopped. If there is no stopping criteria, then you will have infinite loop. So something inside a while loop must eventually make the condition false. So there should be one thing that creates false. Infinite loop means loop that does not have a way of stopping. So there is no way to stop the loop. Let's see. Example 1 and example 2. So which code has the infinite loop? I equals to 1. Okay. While I is higher than 0, then print I. And then the new I will be the old I plus 1. So I can be added by 1, and so on, and so on. So if I start with 1, next I will be 2. So 2 is higher than 0? Yes. And then I will print 2. Now I becomes 3. 3 is higher than 0? Yes. And then again print 3. 3 plus 1 now becomes 4. 4 is higher than 0? Yes. Now the question, when this loop stop? It never stop. Then you will have infinite. Now, let's see what happens when you do this in PyCharm. So it keeps running. So it never stops. And of course, you need to stop by the system. So here you will see the stop button. So you need to force stop. Otherwise, it will keep running. The second problem. J equals to 1. While true. What is it? We know about Boolean. You still remember? a Boolean contains true or false. So if we have a condition, then of course we have only two options, whether it is true or false. We can change this condition into a Boolean value, true or false. So while it is true, we will print J, and then J will be added by 1. And then after this one, we will go back here. Okay, we know that the condition is true. So we will do again print and J added by 1. And then we will check again. Okay, the condition is still true. So we will keep doing this. If you try to run this, so the result is the same. It is infinite loop. Okay. So you need to stop from the system. So what is infinite loop? The loop that does not have a way of stopping. So it repeats until the program is interrupted. So in PyCharm, when I press the stop, so it is the interruption. And usually it occurs when programmer forgets to include stopping code in the loop. So please remember, whenever you make a loop, you need to find some stopping criteria. Now, let's have a problem, and I give you the flowchart. This is a problem of an advanced math learning tool. If you still remember the math subtraction learning. So last time we learned about how to create the subtraction program. And at the time, we just have the math subtraction learning, just one question for each round. So you just give one question and finish. Now, we can use a loop to generate questions repeatedly. For example, I want the student to answer the problem, and if the answer is false, let the student give another answer. So it means it is a loop. Let's see this flowchart. So it starts, and then I have three variables, n1, n2, and answer. Let n1 be n1 and n2 are random integer from 0 until 9. So I would like to check n1 is less than n2. So we know this is the math learning tool for the first grader. It means, yeah, let's try to avoid the negative. If we want to avoid the negative, then the n1 should be higher than n2. So if the n1 is less than n2, let's clap. You still remember what is right? We change the order, okay? And then let's see, answer equals to what is n1 minus n2. If the answer n1 minus n2 is not equal to the answer, let's do. And then again, answer equals to what is n1, n2. Again, if the answer is not the same, then let's do. If the answer is correct, then stop. Okay, so this is the flowchart. How can you make the code? I already give you the code in the pie chart. So the repeat subtraction quiz. So what is 8 minus 5? So let me just give wrong answer. Oh, wrong answer. Try again. What is 8 minus 5? 2. Okay, wrong answer. Try again. What is 8 minus 5? 3. Okay, you got it. So this code starts with random integer. So we have the import random, and then we have n1 random from 0 until 9, and n2 is also an integer from 0 until 9. So if n1 is less than n2, let's swap it. So this is the swap function. And then I would like to get the answer from the user. So this is the input from the user, and we use while. While n1 minus n2 not equal to the answer, then again ask the user to input the correct answer. So it will be repeated until this condition become false. Okay, that's it. If this condition is true, we will do this one. So it means if the answer is false, we will do this one more and more and more, again and again and again. Okay. Next. This is another flowchart. So we are going to make a program guessing numbers. Guessing numbers. So I want to guess a number, and then the first part, I would like to have two variables, number and guess. Number will be a random integer between 0 until 100. And let's make the variable guess equals to -1. So we will check. Guess not equal number. If the guess is not equal to the number, of course it is not equal because guess is -1 and the random integer between 0 until 99. Okay, because this is -1, of course this is true. If it is true, then I would like to get the input from user. Guess equals to enter your guess. Now it will check whether the guess equals to the number. If the condition is true, okay, you are correct. Then finish. But if it is not true, we need to give another condition. The guess is higher than the number. If it is true, yes, it is too high. If the guess is not higher than number, then the number that you guess is too low. It means you can try to figure out whether the correct number is higher or lower. And then after this, we will go back to this one. We know that the guess is not equal to number. So again, guess, enter your number. If the guess equals to the number, this is correct. But if it is still not the same with the number, then again, we will check whether the number is too high or too low. So I have two files, guess one time and guess number with loop. Let's see. Guess number one time. In the guess number one time, we have a random number from 0 until 100 and then guess a magic number between 0 until 100. So we want to get the user input, and the user input will be in the variable guess. Now we will check. If guess equals the number, then okay, yes, the number is done. What is the number that is generated from the random function? But if it is not, we need to check. If the guess is higher than number, then your guess is too high. If it is not, then your guess is too low. So if this one is executed, so enter your guess. Because it is random number, we don't know. Let me just guess 50. Okay, your guess is too high. So maybe it is like 40 or something. But if you just guess one time, it is not interesting. So how can we do this with looping? So we want to know what is the correct answer. The second example is using, so this is from the flowchart. Again, I'm just giving a random number to the variable number, and then I start guess with -1. If guess is not equal to number, then let's get the input from user. So if the guess is equal to the number, then yeah, you print yes, the number is number. If the guess is higher than the number, then your guess is too high. Otherwise, your guess is too low. So if I run this, guess a magic number between 0 and 100. Let me have 50. Oh, your guess is too high. Again, you need to enter number 40. Your guess is too low. It means the number will be in between 50 and 40. Let me give 45. Your guess is too low. Then the number may be around 46 or 47. 47. Oh, my guess is still too low. 49 is still too high. Then 40. Okay, yes, the number is 40. So this is another way to use the loop. Okay, let's have a break. Okay, I will continue after the break.